Alright, in this lesson we're still dealing with ratios, and like I said, this whole chapter we're going to be dealing with ratios. In this particular lesson, the textbook is having us do something a little bit different than I've had to do in years past, but it is a good thing that we're going to do it because when we get into the algebra concepts and the graphing concepts, we will see these tables in those classes, so it's good to see these tables this early. First of all, it says two ratios that describe the same relationship are called equivalent ratios. And it says you can find equivalent ratios by adding or subtracting quantities in the equivalent ratios. In other words, in the numerators and in the denominators, you can add or subtract. Or you can multiply or divide each quantity in the ratio by the same number. And it says you can organize equivalent ratios using a ratio table. Again, lots of wordy definitions, but really what helps us see equivalent ratios is actually working through some of these tables. So the first couple problems here, we're just going to take these tables and try to figure out what the pattern is along the top and along the bottom. So if I look at the top numbers, it's going up by 1, so I'm assuming it's going to go up by 1 again, and I'm going to say that that number in the top right corner is going to be 3. The bottom one is a little more tricky. I have 2 steps to get from 3 to 9, and I want to be doing the same thing in each of those steps. Well, the only way I can do that is if I take 9 minus 3, and I take that and I divide it by 2. When I do that, I get 6 over 2, and I get 3. So I know each one of these things should increase by 3. So my second box in that bottom row should be 6. So it looks like the ratio of pens to pencils is 1 to 3. And then if you'll notice, if we take all of those fractions, 1 over 3, 2 over 6, and 3 over 9, those all are equivalent ratios. Example B is very similar. If you want to pause it and try on your own, that'd be great. If not, you'll kind of follow along here as well. So letter B, we look at the pattern again. I'm assuming because the bottom one went up by 6, I'm going to have to do that for the other one as well. But if I look at this, I see that the ratio is 4 over 6. So if I only went up by 6, this would be 18. And if I look at that, 24 over 18 is not equivalent to 4 over 6. So instead what I have to do is I have to figure out 4 over 6 and then set it equal to 24 over x and figure out what the cross product would be. So if I multiply that up, I would get this. I would get 4 times x is equal to 6 times 24. So the pattern is we're going to be ending up multiplying instead of instead of adding across the bottom. So in the last one we were just adding across the top and the bottom. This one the pattern is multiplication. So if I look at this, I have 6 times 24. So I end up with 4x equals 144. And when I divide that by 4, I get x is equal to 36. So I know my bottom right-hand corner shouldn't be 18, but it should be 36. The top one, again, I want those ratios to be equivalent. So what I could do is I could say 4 over 6 would be equal to what over 12? Well, on that last one I used cross products. You can also just look at these. What do I take times 6 to get 12? I'm going to do that same thing to the top. So whatever I take times 6 to get 12, I would take it times the top as well, and that looks like 4 times 2 would be 8 over 12. So all of those ratios should be the same, all the way across the top and the bottom. Again, paying attention to the patterns, you kind of have to see the same ratio all the way through. So before you practice these on your own, make sure that when you're all done with those boxes, that everything in the first one is equal to 4 over 3, and everything in the second one is equal to 5 over 4. Okay, so hopefully you've had a couple seconds to try these. Again, please make sure you're trying these because it does us no good to not do any of these on our own first. We have 4 over 3 is equal to blank over 6. Well, again, if I look at 3 to 6, I have to take it times 2. I'm going to have to do the same thing to the 4 as well, so it should be 8. Again, my ratio that I want to be equivalent to is 4 over 3 is equal to 12 over blank. So again, whatever I do to 4 to get to 12, I have to do to 3 as well. When I take 3 times 3, I get 9. So 8 should be the top middle, 9 should be the bottom right. 5 over 4 equals 10 over blank. So I say 5 times what is equal to 10. I have to do it to the bottom as well. I get 8. The other one, we have 5 over 4 is equal to blank over 32. Again, if I look from 4 to 32, I would multiply by 8. So I would have to multiply the top by 8 as well, and I would get 40. So sometimes you have to add, sometimes you have to multiply. The cross products will always work here because we have to have equivalent ratios. Every once in a while we can add if everything only goes up by 1. Again, seeing this all the way through the table, the pattern across the bottom only goes up by 1, so I can see for every cup of sugar in this problem that I have that I need to add 4 cups of water. So looking at the problem, it says you are making a sugar water for a hummingbird feeder. A website indicates to use 4 parts water for every 1 part of sugar. So again, the ratio is 4 parts water to every 1 cup of sugar. It says you use 20 cups of water. How much sugar do you need? So again, if I want to do this the long way, here's method 1. We can use a table and we can go up. For every 4 cups of water, there's another cup of sugar. Another 4 cups of water, there's another cup of sugar. And we could continue that until we get to 20 to see that our solution should be 5 cups of sugar. Or the other way would be just to use cross products. So again, if I know that my ratio is 4 to 1 and it says I want 20 parts water and I need to figure out how many parts sugar, I can say what did I have to take times 4 to get to 20, and I do the same thing to 1, and I would use my cross products and get x is equal to 5. So now, looking at this same pattern, again, we're going to use that same thing for number 3. We're going to use the ratio 4 to 1, 4 parts water to 1 part sugar, and it says what happens if you use 24 cups of sugar. So pause for a second and figure out how many cups of sugar. So blank cups of sugar. Okay, number 4. It says you're making a sweeter mixture, so instead of having a 4 to 1 ratio, you're going to have a 3 to 1 ratio, and it says you want to use 9 quarts of water. So with 9 quarts of water, you're still going to have blank cups of sugar. So with the 4 to 1 ratio with 24 cups, again, I have 4 over 1 equals 4 over x. I would take 4 times 6, so I would also take 1 times 6. You should get 6 cups of water. For the sweeter mixture, 3 over 1 is equal to 9 over x. Again, what did I take times 3 to get 9? I have to do the same thing to 1, so I should get 3 cups of water for number 4. So here's basically all we have, you guys. It's a lot of equivalent ratios in mental math. Again, please watch over the video again real quick if you aren't quite sure what was going on there. Ask questions in class, but again, having good notes for these ratios will really help out for quizzes and tests.